এডুকেশন অনলাইন এই অনুষ্ঠানে আপনাদের সকলকে স্বাগত। তনয়া রয়েছে আপনাদের সঙ্গে। নিত্যদিনের মতোই আমরা আজ একটা বিশেষ টপিক নিয়ে আলোচনা করব এবং যে টপিকটা অত্যন্ত গুরুত্বপূর্ণ এবং প্রত্যেকেরই স্কুল প্রায় কার্যত খুলে গিয়েছে, নবম, দশম, একাদশ, দ্বাদশ। সুতরাং প্রত্যেকে তো স্কুল যাচ্ছ, কিন্তু এরই পাশাপাশি যেহেতু উচ্চ মাধ্যমিক একদম সামনে রয়েছে, তো সেই কারণে তার আগের পর্যায়ে দাঁড়িয়ে তোমরা কিভাবে নিজেদেরকে প্রিপেয়ার করবে এবং কোন বিষয়ে কত মার্কস বা কোন প্রশ্নে কত মার্কস থাকে, যেমনটা প্রত্যেকদিন বলে থাকি, তা কিভাবে তোমরা পেতে পারো, সেই সমস্ত বিষয় নিয়ে আমরা আলোচনা করি আমাদের এই অনুষ্ঠানে। এবং আজ আমরা মূলত যে বিষয়টা নিয়ে আলোচনা করব তা হলো রসায়ন এবং একাদশ শ্রেণী। একাদশ এবং দ্বাদশ দুটোই প্রায় একই পর্যায়ানুক্রমে যদি ধরা হয় তাহলে প্রায় একই থাকে। তো সেই কারণের জন্য আমরা একাদশ শ্রেণীর আজ রসায়ন নিয়ে আলোচনা করব এবং এই আলোচনার জন্য আজ স্টুডিওতে যিনি আমাদের সঙ্গে অতিথি হিসেবে উপস্থিত রয়েছেন, আমাদের সঙ্গে বিশিষ্ট শিক্ষক এই মুহূর্তে অর্ণব কুমার দাস উপস্থিত রয়েছেন। আপনাকে স্বাগত জানাবো আমাদের এই অনুষ্ঠানে। এবং ধীরে ধীরে আমরা তাহলে আমাদের মূল অনুষ্ঠানের দিকে এগিয়ে যাব, কারণ স্টুডেন্টরা এবং অভিভাবকরা তারাও ইতিমধ্যে টিভি পর্দার সামনে বসে গিয়েছেন। এবং আজ যখন টপিকটা হচ্ছে রসায়ন নিয়ে, কেমিস্ট্রি নিয়ে, তখন কেমিস্ট্রি মানে একটা আলাদা বিষয় থাকে। 11-12-এর কেমিস্ট্রি মানে মাধ্যমিক, উচ্চ মাধ্যমিকে যেরকমভাবে আমরা মানে অ্যাকচুয়ালি বলতে গেলে যেরকম 9-10 আমরা পড়ে থাকি তার থেকে অনেকটাই আলাদা। এবং সেখান থেকে দাঁড়িয়ে এক কথা বলতে গেলে যখন মাধ্যমিকের পর আমরা 11-এ পা দিই এবং সেই সময় কেমিস্ট্রি, ফিজিক্স এইসব বিষয়গুলোর প্রতি বিশেষ নজর দিতে হয়। এবং এখান থেকেই কিন্তু মূলত আমাদের আলোচনাটা শুরু হবে আজ। এবং স্যার আমাদের সঙ্গে যেহেতু রয়েছেন, সুতরাং একেবারে স্যারের কাছেই চলে যাব। কেমিস্ট্রি মানে অ্যাকচুয়ালি বলতে গেলে রসায়ন এবং পদার্থবিদ্যা দুটোর মধ্যে একটা সাযুজ্য যেমন রয়েছে, একই সঙ্গে পার্থক্য রয়েছে। তবে আজ আমরা আলোচনা করছি স্যার কেমিস্ট্রি নিয়ে।
আচ্ছা, আমি আজকে মেনলি ক্লাস 11-এর অলরেডি অনেকটা স্টেপ আমরা পেরিয়ে এসেছি, মিড সেশন বলা যেতে পারে। তো ক্লাস 11-এর আমাদের যে টপিকস আজকে, সেটা যেটুকু লিমিটেড টাইমের মধ্যে স্টেটস অফ ম্যাটার, এটা অলরেডি তোমরা পড়ে ফেলেছো বা পড়ছো স্টেটস অফ ম্যাটার। সেই স্টেটস অফ ম্যাটারের কিছু টপিকস নিয়ে আজকে আলোচনা করবো। তো আমি হেডিংটা লিখছি। স্টেটস অফ ম্যাটার। নাও এখন আমরা সবাই জানি যে we have 5 states, 4 natural states. These are solid states, liquid state, gaseous states and plasma states, and 1 man-made, that is Bose-Einstein condensate. তো মেনলি যে 3 states এর মধ্যে, solid state, liquid state and gaseous states, gaseous state and liquid state এটা আমাদের ক্লাস 11-এ পড়ানো হয়, আর সলিড স্টেটটা ক্লাস 12-এর একদম ফার্স্টেই। তো আমি আজকে যে টপিক্সটা নিয়ে আলোচনা করবো স্টেটস অফ ম্যাটারের মধ্যে, দ্যাট ইজ গ্যাসিয়াস স্টেট। এখন যখনই গ্যাসিয়াস স্টেট নিয়ে কোনো ডিসকাশন বা টপিক্স আমরা আলোচনা করতে আসব, তখন প্রথমেই আমরা কতগুলো গ্যাস ল নিয়ে আমরা ডিসকাস করব, যেমন বয়েলস ল, চার্লস ল, অ্যাভোগাড্রোস ল অ্যান্ড আইডিয়াল গ্যাস ইকুয়েশন। এবং আমরা এটাও আলোচনা করব যে হাউ রিয়েল গ্যাস ডেভিয়েটস ফ্রম আইডিয়াল বিহেভিয়ার। নাও যদি ফার্স্ট আমরা আসি বয়েলস ল। Now, Boyle's law states, one minute. Boyle's law states that temperature remaining constant, volume of a given mass of dry gas is inversely proportional to pressure. Inversely proportional to pressure means, that means if we increase pressure of a gas, then its volume will decrease, provided temperature and mass, that is number of moles, are constants. So in mathematical expression, pressure is inverse proportional to volume, or you can say volume is inversely proportional to pressure, provided temperature T and number of moles N remains constant. That means if you exert pressure on a gas in an enclosed volume, then its volume will decrease, and the ratio by which the pressure increases, proportionately volume will decrease. Now, volume is inversely, or pressure is inversely proportional to volume, or volume is inversely proportional to pressure. Now, তোমরা জানো যদি আমি প্রপোর্শনালটাকে তুলে দিয়ে ইকুয়ালস টু আনি, তাহলে একটা কনস্ট্যান্ট অফ প্রপোর্শনালিটি আসে, দ্যাট ইজ কে। দ্যাট মিনস ভি প্রপোর্শনাল টু 1 by p, so v equals to k into 1 by p. That k is called constant of proportionality. So pv equals to k equals to constant. That means if we increase pressure, then its volume will decrease, or if we decrease pressure, then the volume of the gas will increase. But the product of pressure and volume remains constant. PV equals to constant. Product of pressure and volume, that will remain constant. This is Boyle's law. Now from Boyle's law, we can derive another relation. What is this? PV equals to constant K, or volume means mass divided by density equals to K, or D equals to, that means density equals to m by k in V. Now for a given mass of a gas, mass is constant and k is another constant. So we can write density is directly proportional to pressure. That means if temperature remains constant, the density of a gas is directly proportional to its pressure. That has been derived from Boyle's law. Now if we look at the graphs of Boyle's law, then we will see that is pressure and volume is inversely proportional. So if we put volume at y-axis and put pressure at p-axis, x-axis, so it's a hyperbolic curve. When pressure increases, its volume decreases. When pressure decreases, its volume increases. So pressure volume graph is a hyperbolic curve, inversely proportional graph. Now another one, product of pressure and volume remains constant. However, the pressure increases and volume decreases, but the product remains constant. So this is the graph in which y-axis we place PV versus P graph. Now if we increase pressure, then PV will constant. If we increase pressure, volume will decrease, but the product PV will remain constant. So the constant graph is parallel to P axis or X axis. This is PV versus P graph. Another one is, we have told earlier that volume is inversely proportional to pressure, but we can say volume is directly proportional to 1 by P. That means volume is directly proportional to reciprocal of pressure. So if I place volume at y-axis and 1 by P at x-axis, then this graph is a directly proportional graph, which is a straight line passing through the origin. P versus 1 by P. These all are the graphs of Boyle's law. Again, in Boyle's law, temperature remains constant. Now, if temperature remains constant, then we will get different graph, different curve at different temperature. That means here we place pressure at y-axis and volume at x-axis. Now, if you look at the hyperbolic curve, then you can see that at 200 Kelvin there is a graph, there is a curve, then 400 Kelvin another curve, and 600 Kelvin is another graph. So we are getting different graphs because at different temperature, because temperature remains constant. So at different temperature, there are different graphs. And the Boyle's law graphs are called isotherm. That means temperature constant, so isotherm. Now I am switching over from Boyle's law to Charles' law. You know Charles' law? Now what Charles states, in case of Boyle's law, temperature is constant, and in case of Charles' law, pressure remains constant. Now, pressure remaining constant, the volume of a given mass of dry gas increases or decreases by 1 by 273 of its volume at 0 degree Celsius with 1 degree Celsius increase or decrease in temperature. This is the Charles' law. Now, I am explaining Charles' law. Suppose pressure remains constant, mass remains constant. Now, for 1 degree Celsius increase, the volume of a given mass of dry gas increases by 1 by 273. Exactly it is 1 by 273.15. I round up, it is 1 by 273 of its volume at 0 degree Celsius. I am considering volume at 0 degree Celsius is V0. So for 1 degree Celsius increase, the volume of a gas increases by 1 by 273 of V0. V0 is the volume of the gas at 0 degree Celsius. Now for T degree Celsius increase, the volume will increase by 1 by 270 by 273 of V0. That means V0T by 273. Now, if we consider the volume of the gas at T degree Celsius is Vt, so its volume will, initial volume V0 plus V0T by 273. From there, or Vt equals to V0 1 plus T by 273 or Vt equals to 273 plus T by 273. Or Vt equals to V0 by 273 into T is the temperature, small t is the temperature at Celsius scale. Now you know that 273, if I add 273, then it will be in Kelvin scale, and that is capital T. 273 plus T is capital T. This capital T is the temperature at Kelvin scale, or Vt directly proportional to Kelvin temperature, because V0 by 273 is a constant. For a given mass of a gas, volume at 0 degree Celsius, that is V0, is constant. 273 is again is constant, so V0 by 273 ratio is constant. So volume at T degree Celsius, that is V, is directly proportional to Kelvin temperature. So Charles' law can be restated as the volume of a given mass of dry gas is directly proportional to its Kelvin temperature if pressure remains constant. Now this is the mathematical derivation of Charles' law. Now if we look into the graph of Charles' law, then we can say this is the graph at Charles' law. Look, in this graph, pressure remains constant in Charles' law. So at different pressure, we are getting different curve. And at 273, what I have told, 273, now if I derive that at minus, when the temperature decreases, when the temperature increases, Kelvin temperature increases, the volume of the gas increases. But when temperature decreases, the volume of the gas decreases, directly proportional. Now, on decreasing temperature, if we reach at minus 273 degrees Celsius, we will find the volume of the gas will become 0, because at minus 273 degrees Celsius, Vt equals to 0. But this is only the theoretical concept, because gas is one of the states of matter and volume of a gas cannot be 0. And at minus 273 degrees Celsius, the motion of the molecule will cease. If the volume becomes 0, then the motion of the molecule will cease, which is not possible. So minus 273 degrees Celsius is a theoretical concept, and according to this theoretical concept, the volume of a gas becomes 0. So minus 273 degrees Celsius, more precisely minus 273.15 degrees Celsius, the temperature is called absolute 0. So this is the graph when temperature increases. At minus 273.15 degrees Celsius, the volume of a gas becomes 0. At y-axis we place volume, and x-axis it is temperature, pressure remaining constant. When we increase pressure, then the volume will increase temperature, then the volume will increase. But at minus 273.15 degrees Celsius, the volume will become 0. Before reaching this temperature, all gases will liquefy or solidify. So volume cannot be zero. Minus 273.15 degrees Celsius is only a theoretical concept. It cannot be reachable. Now, come to Avogadro's law. What Avogadro's law states? Pressure and temperature remaining same, equal volume of all gases contain equal number of molecules. I am giving an example. Suppose nitrogen and hydrogen combines to form ammonia gas. Here reactants are gases, nitrogen and hydrogen, and product is also ammonia, is also gas. Now, again I am telling, if temperature and pressure remains constant, then equal volume of all gases contain equal number of molecules. Now, if I say nitrogen is one volume, and if it contains n number of molecule, then hydrogen, one volume of hydrogen will also contain n number of molecule, one volume of ammonia will also contain n number of molecule. So 3 volume hydrogen will contain 3n number of molecule, and 2 volume of ammonia contains 2n number of molecule. This is the mathematical, or you can say that an example we can explain. Now, if I again explain Avogadro's law, equal volume of all gases contain equal number of molecule means if we increase volume of a gas, then its number of molecule will also increase. Now, if I represent capital N as a number of molecule, molecule, then if volume increases, then number of molecule will increases. Now, if number of molecule will increases, number of mole will also increases. Small n will represent number of moles of a gas. This is the mathematical expression of Avogadro's law. Now again, K is a proportionality constant, constant of proportionality. V equals V proportional to N, number of moles, and V equals to K into N. Or K means number of moles, so we can write small n as small m and capital M. Small m equals to given mass and capital M equals to molar mass. Okay, you know, number of moles equals to given mass divided by molar mass. Or M equals to K into M by V. or molar mass m equals to K into a small m is the mass of the gas, V is the volume of the gas, mass divided volume, that is density, or m molar mass is directly proportional to density D. That is, if temperature and pressure remains constant, the molar mass of a gas is directly proportional to its density. We can derive this formula also from Avogadro's law. Now, we have already studied Boyle's law, Charles' law and Avogadro's law. Now, the gas which strictly follows Boyle's law, Charles' law and Avogadro's law is called ideal gas. In reality, there is no such ideal gas. That is what you see, carbon dioxide, ammonia, nitrogen, hydrogen, oxygen, the real gases do not follow Boyle's law, Charles' law or Avogadro's law strictly. Why? Why real gases do not follow Boyle's law, Charles' law and Avogadro's law? Then from there, first I derive ideal gas equation. What is ideal gas equation? Now from Boyle's law, we get volume is inversely proportional to pressure. That means here temperature and number of moles remains constant. This is from Boyle's law. From Charles' law, we get volume is directly proportional to Kelvin temperature when pressure and number of mole remain constant. And from Avogadro's law, we get volume is directly proportional to number of moles when temperature and pressure constant. First is Boyle's law, second one is Charles' law and third one is Avogadro's law. Now if we combine these three laws, then we can write volume is inversely proportional to 1 by P into T into N. And you know, from proportionality, we can get a proportionality constant. Now this proportionality constant will not be K, this will be R. V equals to R into 1 by P into T into N, or Pv equals to nRT. This is called ideal gas equation. It is a combination of Boyle's law, Charles' law and Avogadro's law. Pv equals to nRT. And ideal gas strictly follows Boyle's law, Charles' law, Avogadro's law, that is ideal gas equation. But real gases do not follow strictly these three laws and do not follow ideal gas equation. Now, what is the reason behind this? Why real gases are not following, they are not following ideal gas equation. Now, Pv equals to nRT. I am to mention this R is universal gas constant. Universal gas constant. Its value is 8.314 joule Kelvin inverse mole inverse, or you can tell 0.0821 liter ATM Kelvin inverse mole inverse, or you can tell 0.083 bar. Bar is the unit of pressure like ATM. Liter bar Kelvin inverse mole inverse. R is universal gas constant. Now come to the point of real gases. Now in case of ideal gas, there are few assumptions of kinetic molecular theory of gas. Now, in case of kinetic molecular theory of gas, there are two assumptions which are found wrong or which do not hold good for real gases. What are those faulty assumptions? Number one assumption is, according to kinetic molecular theory of gas, there is no force of attraction between the gas molecules when the gas is enclosed, they are enclosed in a certain volume. If there is no force of attraction, and that's why gases can expand and can occupy all the entire available space they can occupy. Now, in case of real gases, the force of attraction between the gas molecules are minimum. But according to kinetic molecular theory of gas, there is no force of attraction between the molecules of gas. This is number one faulty assumption for which real gases deviate from ideal gas, behavior of ideal gas. Another one is, according to kinetic molecular theory of gas, the molecule occupied space, the gas molecule occupied space, the volume of the gas molecule is negligibly small as compared to the empty space. That means, suppose in a container certain volume of gas are enclosed. This is volume V. Now there are some gas molecules, they are enclosed. According to kinetic molecular theory of gas, the volumes, individual volumes of the gas molecules are negligibly small as compared to the empty space available to them. But according to real gas, the volume of the gas molecules cannot be neglected. So, according to ideal gas, first is, according to kinetic molecular theory of gas, which applies for ideal gas, there is no force of attraction between the molecules of a gas. So, molecules are free to move and they are colliding themselves, and also they are striking on the walls of the container. And you know, pressure is the force per perpendicular force per unit area. So, gas molecules exert pressure in all directions and colliding with among themselves and with the walls of the container. And this is the pressure of the gas molecules, pressure exerted by the gas molecules on the walls of the container. Now, according to real gas, in case of real gas, the gas molecules which are enclosed in a certain volume, they have force of attraction. Although it is minimum, but they have force of attraction. Now, if we increase pressure, then the volume will decrease and the molecules will come closer to each other. The force of attraction among the molecules will increase. And the molecule will dragged by the other molecules. Suppose this molecule is dragged by the other molecules. So this molecule will not collide or will not exert on the wall of the container pressure of the will not exert pressure on the walls of the container as it was in case of ideal gas. Because in an ideal gas, there is no force of attraction among the molecules. Molecules are free and they exert complete pressure on the walls of the container. But in case of real gas, the molecules are dragged by the other molecules. They will not exert complete pressure on the walls of the container. So the pressure of real gas will be less than the pressure of ideal gas. So according to PV equals to nRT, which is an equation of an ideal gas, there is a necessary for correction of pressure. In case of pressure, we can tell in place of P, we can tell P plus A n square by V square. P plus A n square by V square. A n square by, because the pressure of the ideal gas, you can take pressure of the ideal gas, P ideal, equals to P real plus A n square by V square. P ideal is equal to P real plus A n square by V square, because the pressure of real gas is less than the pressure of ideal gas. So this correction term A n square by V square, this is correction term. Again, according to ideal gas, or according to kinetic molecular theory of gas, the volume occupied by the molecule is negligibly small as compared to the empty space available to them. But in case of real gases, this is not negligibly small. The molecules have volumes, and you know that when a molecule is in motion, its volume becomes 4 times than its real volume. This is called excluded volume or co-volume. So the volume occupied by the gas molecule cannot be neglected. So in case of ideal gas, volume was written V. But in case of real gas, we will write pressure in case of P plus n square by V square, already explained. And instead of V, we will write V minus NB. Now, if this NB equals to volume of gas molecules, because volume of gas molecules cannot be neglected in case of real gases. So now, if a gas is enclosed in a certain volume V, the molecules have the empty space is V minus NB. So pressure is corrected to P plus A n square by V square, and volume is corrected to V minus NB equals to nRT. This is called real gas equation, or you can tell this is Van der Waals gas equation. Van der Waals gas equation. PV equals to nRT is the ideal gas equation. P plus A n square by V square into V minus NB equals to nRT is called Van der Waals gas equation or real gas equation. And A and B both are called Van der Waals constant. Now, what is the significance of A and B? Already we have known that, we have come to know that in case of real gas, there is a force of attraction between the molecules. It is minimum but not negligible. So, A is the measure of force of attraction among the molecules. The more the value of A, the more will be the force of attraction between the molecules. And another thing, another deviation has been observed, that is molecules of ideal gas is free to move, there is no force of attraction, and the volume of the molecules will be, volume of the gas molecules will be negligibly small as compared to empty space. So the total volume will be V in case of ideal gas, but in case of real gas, the volume of the gas molecules is NB. So the movement of the gas molecules is restricted within V minus NB. Now this B is the effective size of the gas molecules. And again, what I have told, if a gas molecule is in motion, then its effective volume will increase by 4 times. So that B equals to 4V. If V is the gas molecule, then actual volume of the gas molecule is V. If it is a small v, then its effective volume will be 4V. So V signifies effective size, effective volume of the gas molecule. This is the significance of A and B. Now, in certain condition, real gases can obey ideal gas equation. Certain conditions. What is that? When we decrease pressure of a gas molecule, the volume will increase. And if we go on decreasing the pressure, continuously if we are decreasing the pressure of gas molecule, the volume will increase. And if the volume will increase, gas molecule will move far apart from each other. And the force of attraction between the gas molecule will decrease. And at time when pressure is approaching 0 or tends to 0, at that time, the volume will move far apart from each other and there will be no force of attraction between the gas molecule. And real gases will obey ideal gas equation. And another one is high temperature. If we increase temperature, the volume of the gas molecule will expand. Volume of the gas will expand means the molecule will again move apart from each other and force of attraction will decrease. So, if a real gas has to obey ideal behavior or ideal gas equation, then the molecules of the real gas will be, there will be no force of attraction among the molecules of the real gas. And that possible in case of very low pressure and at very high temperature.
বেশ, এত সুন্দরভাবে স্যার পুরো বিষয়টা তুলে ধরলেন এবং এত সুন্দরভাবে বুঝিয়ে দিলেন যে এরপর মনে হয় আর নতুন করে কোনো প্রশ্ন এই মুহূর্তে স্টুডেন্টের মধ্যে হয়তো নেই। তবে হ্যাঁ, অবশ্যই পড়াশোনাটা তো জারি রাখতে হবে এবং স্যার যেমনটা বুঝিয়ে দিলেন এই চ্যাপ্টারটা যদি তোমরা আরও একবার এই মুহূর্তে রিভাইজ করে নাও তাহলে হয়তো তোমাদের বুঝতে আরও সুবিধা হবে। তবে এখন যেহেতু আমাদের হাতে সময় একদম নেই, অনুষ্ঠান আমাদের শেষ করতেই হচ্ছে। অনেক অনেক ধন্যবাদ জানাবো স্যার আপনাকে আমাদের এই অনুষ্ঠানে থাকবার জন্য। এবং একই সঙ্গে দর্শক বন্ধুরা যারা আমাদের সঙ্গে এতক্ষণ ছিলে, তোমাদেরও প্রত্যেকে একটাই কথা বলবো, অবশ্যই যেমনটা একটু আগেই বললাম যে স্যার যে চ্যাপ্টারটি বুঝিয়ে দিয়েছেন একবার যদি তোমরা সময় করে একটু চোখ বুলিয়ে নাও তাহলে হয়তো কোনো সমস্যা নতুন করে তৈরি হবে না এই চ্যাপ্টারের থেকে। তবে আজ বিদায় নিতে হচ্ছে, প্রত্যেকে খুব ভালো থেকো।